Yeah, I just might have to speak a little bit louder.
Mm.
So, hello. If you are watching this recording, I'm here with Jesse, and I'm giving him an overview of Thothlab and the way how it create a scalable topology. So you will log into Thothlab, and by the way, there is no guarantee that this demo will actually work. So if it doesn't work, just bug Jake about what he learned today. So there are two networks that you can see on your screen right now. The first one is known as test environment, and it has a lot of team members that have been added. And if you click on start lab, you will be able to see the topology that I deployed for that team. And the basic idea of this topology is that there is a router and there are a bunch of virtual machines behind the router. So let's try to see if this attacker, which is our Kali Linux machine, is able to do some stuff. Password for most of these machines is 12345 6. And last time we tried, the Kali Linux was actually able to reach some of the machines that were behind the firewall. If you cannot connect to a certain machine, it is most likely because we do not have routing enabled, and that actually makes sense because we only want the outside users to connect some of the machines behind firewall based on whatever routing we configure. So if you log on to the router machine and do ls, there was a certain routing script that I created, and if you are not able to find it, just type history grep route. Yeah, so it shows you the location of this routing script. So we will go to this project b1, we'll go to code, we'll go to deception scripts, not here, maybe under attack scripts, no. Let's just do find. And it is located somewhere inside this route fuzz folder that I created. So under deception script, if you check route fuzz and if you look at the route forward, So this is basically the routing script that I created. What it says is that any traffic from the Ethernet 0, which is connected to the attacker end user, to the Ethernet 1, which is connected to the internal network, allow it, and the same rule in the reverse direction. And another rule that we have for NAT, which basically does the network address translation, so it basically masquerades the IP of outgoing traffic with the IP of that current interface. So for example, if traffic comes from private network and it has IP 192.168.2.0 something, what this rule will do is masquerade that IP with the IP address of the router that we have here and send the traffic out. And this last rule basically says that enable forwarding on this machine. It is a kernel module where we have a specific setting to enable forwarding, and if you run this script on the router, currently it is already running, so that will enable the forwarding in both direction. So anytime if you shut the router down, you can run this script again to enable traffic. So let's do if config. You can see that the interface 1 is 1.20 and interface 0 is 2.18. Let's go back to topology again and access a particular virtual machine. One, two, three, four, five, six. So if we do if config and grep ETH, there are a lot of interfaces because of the containers running on this machine, but we are interested in this ENS3. So this ENS3 is basically the interface which is connected to the router. So this VM2, like even if you hover over the VM icon, you can see the IP address that is connected to the switch, which is in turn connected with the router. So let's try to see if attacker can ping this IP address, and if he cannot, then I'll explain why is that not happening and how we can enable communication. Yeah, so it is not able to ping 1.5, and what we simply need to do is go on this machine and set the gateway of this machine to the router. So we have to set the gateway of VM2 to this particular IP, and how we check those values is using the commands that I'll type next. I do route -n, there is a single O. So currently you can see that gateway is 1.1 and I want to set it to 1.20. So I run the command sudo route del default and sudo route add default gateway 192.168.1.20. Then let's come to attacker again. Bingo. So very simple. Anytime you want a machine to be connected to attacking network, simply go to that machine and change its gateway from the current gateway to this router gateway, and after that everything will work seamlessly. Well, hopefully. Now we'll have a look at how we can mess around with this topology. So you will go to this URL openstack.thothlab.com. Let me have a look at the correct URL. Yeah, so it is .com and I wrongly inserted .org. So you will be directed to this OpenStack page, and I'll be asking Jesse to log in with his credentials, because if I log in with my credentials, you will see a whole lot of information apart from your particular network. So can you type in your credentials? No.
Oh, on here? Oh.
On here, yeah. So these credentials will be same as your Thothlab credentials, and in the domain you just need to type users.
I use so many.
Yeah, so we are currently inside the backend from where we can mess around with the topology. So there are mainly two tabs we need to be aware of. One is instances. If we click on the instances, and currently you will see that under users there are two projects assigned to your team. The project one is the selected project by default, and I'll also explain you why I set up second project in a bit. So if you click on instances, you will see specification of different machines that we have set up, and important thing to remember is the flavor that you can see here. So if you add new machines, basically remember the flavor that you have present here. So basically this is one important tab that we have, and let's try to basically delete and recreate one of the Windows machines, because Windows 2016 is currently maybe not working well, so also it is shut off. So if you check this and delete instance, it will purge the machine. And let's add a new machine here. So let's call it VM new. Mostly it is just next. Let's select Windows 7. Go to next and select medium. M to medium actually. Next, and we can select the switch to which we want to attach this machine. Let's see which switches we have. You can see that switch 2 is connected to attacker and user and switch 1 is connected to these machines. So let's select switch 1 and launch instance. Looks like it didn't work. Let me try to see why it didn't work and relaunch this instance. Let's call it VM3. Go to next. Select test Windows 7. Okay, so back again to this screen. The reason for error was that we were trying to create a volume. So when you select image, create volume should be set to no. And from here we can just select this test Windows 7. Next, come to medium. Next, switch 1, launch. Yeah, and as you can see that this will be in spawning mode and soon it will be deployed. So from backend also you can access the console. So this is one major screen from where you can launch different virtual machines. And the second main tab here is this network, and if you go to network topology, yeah, so this will show you different network topologies that we have. This is your attacker machine, this is your user machine, this is our router, and these are the normal machines that we deployed. VM1, VM2, VM5, and this is basically the graphical view of what we have. If we go to networks, what we can do is basically create different switches which we can connect to the router. So let's try to create one more subnet. I'll call it switch 3, subnet name again switch 3, network address 192.168.3.0/24. Select next and create. And we go back to the network topology to check what changed, and you will see that this switch 3 that we created should show up in our topology. Yeah, so this red part is basically switch 3. And to this switch basically you can add the interface of these different instances that you have as part of your network topology. So we can see the different details of the ports that can be attached to this switch. It shows you that this switch is able to offer the DHCP service. So the new machines that you create, if you add that machine to this switch, basically it will take IP address from the switch. So let's try to do one thing. Go back to instances and create a new instance which we will attach to this particular switch. Since we deleted VM4, let's call it VM4. And again create new volume, no. Let's select Kali GUI. Go to next.
So do all these so if we just create a bunch of we use a bunch of those routers, are they pre-made with all the scripts that you have in them already?
No, so it is basically same as real world. When you attach a router to your network, it comes clean slate. So you need to enable networking in that router. Try to connect it to machines on internal and external network. So let's connect this one to switch 2 as well as switch 3. And as you can see, I connected it to switch 2 and switch 3. So this machine, once it is spawned, you will be able to see the change in the network topology. Yeah, so this is VM4. We attached it to switch 2 and switch 3. So you might notice it is a little bit better than what we were doing in CyberWAN. And if I go to compute again and click on instance, so there are a bunch of options available here as well. If you click on an instance, so you can also do the similar operation on a running machine using attach interface or basically detach interface. So suppose I want to connect VM6 as well to this switch 3. I can basically attach this interface. So very flexible way to manage the networking of a VM. And basically let's go back to network again and check the network topology. Yeah, you can see that VM6 now is attached to both switches. So to give the overall high level picture, there is an external network which is connected to switch 2 using this virtual router. You don't need to worry about that currently. And you can create different subnetworks. Each subnetwork will be under a specific switch. And you can attach different virtual machines to different switches. So what I have done currently is that only router can access the external network or internet using this particular switch 2, and everyone else who needs to connect to internet need to send their packets through this router. And that is what you will see in this topology, and that is why we have all the routing scripts on the router. So anyone on private network who tries to communicate to internet, router checks if it is basically legitimate traffic and basically allows that. And when we did the cyber deception project, basically that was some similar approach that we followed. And basically if attacker is trying to access internal machine, you can do some kind of deception at the router and deceive the attacker.
Will refreshing on here show the new changes, or do you have to kind of log out?
Probably, yeah, this should appear. If not, try clearing cache. Yeah, but you can, yeah, like
Oh yeah,
it
it's something
currently
different
shows up
there. Yeah.
the kind of mess of
Yeah.
a network that we created. So yeah, basically we use from the front end Thothlab, and if we want to mess around with the network, go to this
Mhm.
openstack.thoughlab.com and use the options that I showed you.
Um, is there a way to make it to where we can make our own separate topology, or do we have to mess with
So you
just the
need to
current
do
one?
everything under here, like create different subnetworks
Okay,
in this
just just
project, which
yeah, just because
can be managed.
Tiffany was wanting us to have our own, like making our own topology. I mean, I don't know if we
So
discussed if that was
that
possible.
I talked to other people who manage Thoughtlab, and they
Hmm.
are not okay. Like they are not okay with giving privileged access to everyone.
I wouldn't think so. But
So you need to have an admin privilege, and they don't want, first of all, other networks to be messed around with, and that is a security reason. And currently we are running low on compute, so the idea is that we give you sufficient storage here, and
hmm.
you basically mess around with this network.
Okay.
The second thing that I wanted to show today was towards the end of basically dealing with this resource limitation that we have. And as you can see, there is a second network present here known as Deception 2.
Hmm.
So idea on this network is to create a scalable topology. And my current reservation is that this recording thing might not basically stop at 35 and tell us, hey, you need to pay for.
Hmm. More time.
Yeah, like I said, if there is issue with the recording, Jesse will be the person whom you can get hold of. So what are we doing here? Let us see. As you will open the topology, you will see a master 1 and 2 worker nodes. What does that mean? Basically, in Docker, you get this option of creating swarms. The idea is that there is a one master node and a lot of worker nodes that join to that master node. So anytime you are trying to scale up your infrastructure, I can add more workers.
Hmm.
Each of these machines is basically a Ubuntu 16.04, and on each machine you will find a bunch of scripts which have been executed already.
Hmm.
Let's check them one by one. If I do cat docker.sh, this script basically sets up the Docker environment on a particular machine.
Hmm.
If I do cat firewall ufw, which is a firewall module, so this basically opens up ports so the worker nodes can connect to the master node. And after this is run,
Hmm.
basically you will be able to see a bunch of configuration information. So the third script is the create master. What this does is that on the local IP 192.168.1.10, it creates a master node and it advertises itself that anyone who wants to join this swarm
Hmm.
can take this token and join this swarm. And the detailed tutorial for this is basically you can just Google Docker Swarm Ubuntu
Nope, keep going.
Yeah, hopefully it doesn't screws us when I try to explain something important and it says, oh, now you need to pay up. Yeah, so basically go through this documentation and it will tell you details of how I did it. And if you want to set it up on your local, basically run my scripts which are present here, and I'll also upload them to a Git repo. So when you do swarm init, it basically creates a swarm, and the IP will be the IP of the machine on which you want to create a master. And using this join command that I have here, you can join this swarm. So when I go to worker 1, I need to install Docker on this machine, open up ports similar to how I did on master, and basically run join swarm, and it joins the master. So currently I have one master with 80 gigabits of storage and 8 gigabits of RAM and two worker nodes. So on the master, if I check sudo docker node ls, and password is 123456 as always. So once all of this is set up, you will see that this first node master 1 is basically manager and the other two nodes are worker. So this can help us basically create and scale topology in container environment, and that is the idea that I have for creating a more scalable topology. And the second thing that we will talk about is Containernet, which is basically used for creating this container based network which is scalable. So how we create images on Docker is basically we pull a certain image from the Docker hub. So for instance, if I want to create a metasploitable image, I can basically do a Docker pull peak with 3Ks and metasploitable. I wish it had a separate tab option, but uh, it is what it is. So while that metasploitable image is pulling up, let me tell you what this container D is. So Containernet takes the networking feature of something known as Mininet, which is a network simulator, and instead of the dummy nodes which are used in Mininet, it basically adds container hosts as the nodes. To have Containernet on your master and slaves, you will basically need to follow this first option, and this is also present on all machines in form of this file containernet.sh. So it basically sets up the background mininet, creates a bunch of networking, and basically starts a small network. And after all of this is done, it takes a while. Let us have a look at a small coding example that they have provided. So this small example has two Docker containers D1 and D2 connected to two switches S1 and S2. So this Python code basically adds a controller, adds two Docker nodes D1 and D2 whose image type is Ubuntu Trusty, adds two switches, very simple code to follow, connects the D1 to switch S1, connects the D2 to switch S2, and connects both switches to each other, and basically starts a network and provides the checking if the ping is working. And on the worker nodes as well, the code works similarly. Looks like this recording software froze my browser for some reason. Let me open Thothlab again. Yeah, so it was able to pull up this metasploitable. You can see all these images. So when we create our network using this mininet code, we can add these images in our network. So the idea is that we create small networks over these three nodes and manage them together. So the Swarm master will have the controlling functionality, and we create like small subnetworks on the workers and masters, and together it adds up to a very scalable topology. And if you go to this Containernet folder and go to the example, there are multiple examples of different types of networks that we can create. So you can check out these examples and try to see how we can create a tree topology and basically different types of scalable topologies that we want to build. If we go to Containernet and Mininet, there are more examples. So all these examples will give you a fair idea like how the scalable network can be created. Let me quickly show you the code again. So basically we are adding two switches to each other, the Docker host to the switches and the switches to container. Fairly simple example, and let's try to run this example. It will take a minute or so to set up. But once it sets up, you can see that you get a Containernet terminal, and you can see different options using this different commands. So I would suggest go to this Mininet tutorial to familiarize yourself with the different commands that are present. Like there is a command to check the network using net, and help nodes displays the links that are present there correctly. Let's try to run nodes. And Jesse is looking at his watch, so I'll try to speed up.
Oh no, sorry. It was no, definitely not.
So I'll do a ping all. It shows that Docker 1 connected to Docker 2, Docker 2 to Docker 1, 0% packets dropped. And this is the idea how we can create a more scalable topology. Let me try to open another terminal and show you the containers that are present in sudo. So you can see these different containers, like the mn.d1 and mn.d2 are the ones that got created, and there is a bin bash. So to work on a scalable topology, two important things. One is familiarize yourself with Mininet, and second is Docker commands, Docker tutorial. So once you basically go through these, you will be able to write your own Python code similar to the container example that I showed you. And there are plenty of examples, as I mentioned in the Containernet examples. And using Mininet, we can create several scalable topologies, and these are actual hosts that are connected to each other because they are Docker containers. So lastly, on my GitHub, I created this kind of project called cyber deception. And I have cloned a lot of repos of Containernet, Mininet, another topology that Tiffany wanted to have a look at. Then there is internet zoo topology, which is basically a list of different scalable topologies. There is this assessing mininet, which basically takes internet zoo topology and converts it into a mininet topology. Like this particular code created a mininet topology from internet zoo topology. So send me your GitHub ID so I can add you to this repo. Currently, I have give ownership to myself and Tiffany. I sent her this afternoon. Yeah, so I'll need your GitHub IDs to add you to this. So to summarize what we discussed, we checked the first topology in cyber deception. All of you have access to this topology. If you want to mess around with this topology, you will need to go to openstack.thothlab.com, which is this. We discussed that there is instances under compute. To create instances, to mess around with network, there is this network tab. Those are the two important ones. Then we talked about this second topology known as deception 2, and I mentioned that I created something known as a Docker swarm. Docker swarm will basically help us create a very scalable framework where we can keep on adding the compute nodes. There is a master node and two slave nodes, and this document tells how we add master and slave nodes. Then Containernet is a framework which takes the mininet networking part and combines it with the Docker instances. So basically, you can create a scalable network where the hosts are not something simulated but the actual Docker instances, and this will be used to do that. And lastly, I mentioned that you need to be familiar with the Mininet walkthrough and little bit of Docker so that you can work with your own code. And the code that I showed you for the basic topology is known as container example. It is present on this master node, container example.py. So have a look at this. Go to Containernet and check out other examples which can be used. Try creating some of the topologies under this, and let's see how it goes. And now I'll try to see if this video recording saves actually.